Good evening. Today it is 9/24/2015. And this morning in class, if you wasn't there, this video is definitely for you, but if you were, still it's good. Today in class we talk about dilation, and this is your standard. So, take some time, write down your standard, read over it, get to know your standard a little bit. Okay, take some time, pause it, write it down. Alright, key vocabulary that we need to know starting dilation. First vocabulary word is similarity. The corresponding sides are proportional and the corresponding angles remain congruent. So what that means is if you actually look at similarity, you have two similar triangles. Triangle ABC is similar to triangle DEL. If you were to actually look at it, let's give it some numbers. So you might have 5 here. Oh, let me correct that. You might have 5 here, 3 here, and 4. All right. And here you might have 2.5, 1.5, and 2. So if you look at it, the sizes are different. ABC is actually longer. Sizes are longer than DEL. So if ABC was our image and DEL was our pre-image, meaning our beginning image, that means it was an enlargement between the two figures. That DEL was dilated 2 times to become ABC, or vice versa. ABC was dilated to shrink to DEL. In order to shrink or reduce, you would have to multiply by a fraction. In order to enlarge the picture, you have to multiply by a number greater than 1. Okay? But most of the time when we think about similarity, we think that two figures are similar. They are the same shape but different size. But you have to kind of really go into it. The corresponding sides are proportional to one another. And your angles that remain in there are going to be congruent. So if one angle is 30 and one triangle is also 30 in the other one, even though triangles may be bigger. Okay? So our next vocabulary word we're going to go to is dilation itself. Dilation is a transformation that changes the size of a figure. Now, when we think of all our different transformations, you have translation, rotation, and reflection. And now we're going to add dilation. But the first 3, translation, rotation, and reflection, those 3 are rigid motions. And if you remember from our previous lessons, that rigid motion do not change the shape or size. It does not change the size of the figure. The rigid motions remain congruent. So if you were to translate, rotate, or reflect the picture, it will stay congruent. But we're actually talking about similarity now. So dilation is the only transformation that actually changes the size of the figure without changing the shape. Okay, so kind of give you a picture of that. All right, take a look at it. If you look at the penguin, the pre-image, so that means the beginning image, was a big penguin. Then it got dilated, or dilation happened, and it transformed into a reduction of the smaller image that you see here. That's the smaller image that you see here. So it went from the big penguin to the smaller one. So the same thing happened for this one. So the American flag that's on our United States countries went from these small pre-image to this United States map, this bigger image. This is a special word, enlargement and reduction. You're going to hear that a lot when you come to class. Enlargement and reduction. But the main thing that tells us how the enlargement or when the enlargement is going to happen and when the reduction is going to happen is through our scale factor. Our scale factor is the ratio of any two corresponding lengths. Your scale factor will tell you how much bigger a figure can get. If it's going to get 2 times bigger than its original image, or it's going to get 1/2 the size of its original image. So if I go 2 times big, 2 times a figure, that means I'm going to get bigger. If I go 1/2, that means the figure is actually going to have to shrink. So let's look at one. Alright, so you got square A and square B. Oh, my bad. Rectangle A and rectangle B. One side of A is 3, and the other side is 5. So one side of this rectangle B is 9, and this side is 5. So you can look at it and kind of see what kind of scale factor it has. So if I was to go from A to B for dilation, that means that this side scale factor had to get multiplied by 3 to become 9. And this side, which is 5, had to get multiplied by 3 to become 15. Okay? So an enlargement, let me kind of write it up here. Enlargement scale factor is greater than 1. But let's say we want to do a reduction. So we're going to go from rectangle B to rectangle A. So rectangle B is a reduction. Sorry, I didn't put scale factor when I said scale factor. Yeah. Alright. The scale factor is less than 1. Or to think about it, less than 1 or a fraction. So if we were to change rectangle B into rectangle A, it would be a dilation, but it would be a reduction, and it would have to be a fraction that's less than 1. So if we multiplied it by 3 to go from A to B, we would have to multiply by a fraction of 1/3. So an example of that, a fraction of 1/3 times our corresponding size. So 15 will get multiplied times 1/3 to reduce to 5. And 9 will get multiplied by 1/3 to reduce to 3. Yes, I know that you are thinking it is simpler to just divide, but when you are dealing with a scale factor, you will always multiply. Okay? You will always multiply. Alright, and our last one that we're going to talk about. Is center dilation. Sorry about that. Center dilation is a fixed point on a plane about which all points are expanded or contracted, which means that it's going to get either further away from the center dilation or it's going to get even closer to the center dilation. It's going to enlarge your picture or it's going to reduce your picture, your figure or picture. So let's see what center dilation looks like. So our center dilation for this particular picture is the point O. So ABC was dilated from the center dilation of O. So the first ABC, which is the pre-image, which is here, was pretty much very small. It was enlarged. If you look at it, it was enlarged to this bigger A prime, B prime, C prime. But if you notice, all points like A prime and A, their points still draw back to the center of dilation. So does B prime and B. They all go back to the center of dilation. And also C does the same thing, go back to the center of dilation. So if these two figures are very similar, like they're supposed to be, then all the points will draw back to a center of dilation point. So they all will draw back to one particular point. And then since this point is actually fixed, this point doesn't move, but the A itself had to change into A prime. It had to move. So same thing with B. B had to move away from O to become B prime. C has to move away from O to become C prime. Alright, I hope this helped you out to understand the beginning. Okay, if it didn't, let's get ready for the next video.